I am Pankaj, and today we are going to discuss depth first traversal, which is also known as depth first search. So let's begin. So what is DFS? So it's an algorithm to search in a graph. So basic idea is we go forward and in a depth, and if there is dead end, means there is no possibility such as possibility. So we move backward, means backtrack. So we use stack in it to remember the nodes. So stack help us to start from the next node when there is dead end condition occurs. So this algorithm works in all type of graph, like as directed, undirected, weighted, unweighted, etc. And so what is there? So as you can see, we start from a node which we normally call root node. So if uh, root node is visited, then we move to its neighbor. So if uh, as neighbor, which is x, is not visited, so we visited, then we apply DFS on that neighbor. So let's understand it by an example. So there is a graph which is directed, and we have made a stack which is empty because there is no node is visited, and there is also an array of visited nodes. So we begin with A. So A is visited. So we have marked it in that array that A is visited, and we put A in a stack. Now there is only one possibility from A, which we can see here. There is it is directed, so we can move only in one direction. So we move, we can visit only H. So we have visited H, and we marked H visited, and we put H in the stack. Now there is two possibility from H, F and E. As we can see that we can go in both direction from H and H to F and E, but we can choose any one of them. So we choose E, and we have marked E visited, and we put E in the stack. Now from E there is only one possibility, so which is D. So we visited D, and we marked visited D, and we also put D in the stack. Now there is two possibility from D. One is B and one is C. So we can visit any one of them. So let's we can took anyone. So let's took C. We can took anyone. So we took C. Sorry, B. So we have visited B in we have marked B as a visited, and we have put B in stack. So now we can go forward, and we can go. There is three adjacent of B. One is A, one is F, one is Z. So we can go, but A is already visited. So now we can choose only F and G. So we can choose one on any one of the any one of them. So let's choose F. So we mark F as a visited, and we put F in the stack. So now there is only one possibility from A where we can go, which is G. So we will move G, and we have marked G as a visited, and we put G in the stack. But now there is no adjustment of G, so we have to backtrack. and at this time the stack will be useful for us. So now we will understand the concept of stack clearly. So from G there is no addition, so we will backtrack. So mean we will move to, so we will backtrack and we will remove G from here. So as we have mentioned, the we have no node addition to G cannot continue, so we have to backtrack and we have to pop G from the stack and restore previous state. So we have pop up G from here. Now there is F. So as you can see that there is no state where which is not visited of F. So we have to continue. We have to again pop the F and continue. So we have pop up the F and now there is B. So as we can see that the all the additional edges of B have visited. A is visited, F is visited, and G is visited, which is reachable from B. So we have to again pop up and continue the process. So we have pop up the B and we have now on D. So we can see that we can reach there are two adjacent edges of D where we can reach from D. One is B and one is C. B is visited now, C is remained. C is unvisited. So we can move to C. So we will move to C. So now C is we have visited C and we mark C as a visited and we put C in the stack. So now there is the same case again like as G. So there is no adjacent edge of C, so we cannot continue and we have to backtrack and pop the C from the stack. So we pop up the C from the stack and now there is we have arrived on D again. So D, as we can see that D have only two edges, sorry, two nodes which have already visited. So now we will move, we will pop up D from the stack. So we have pop up the stack. Now there is only E and there is no adjacent of E which is unvisited. So we will pop up E and the process will be continued. So we have pop up E from here and now there is edge. So as we can see that there are three edges which can be reachable from edge. One is F, one is E. So F and E both are visited. So there is no adjacent edge of edge which is not visited. So we will pop edge and process will be continue. And now there is only A which is in the stack. And as you can see there that there is only one stage, but one additional edge of A edge which is reachable from A and which is already visited. So we don't have to visit and we can pop A. So we will pop A. So now we can see that the whole stack is empty and the array is already as we can see that all the nodes and vertex is visited. So now the traversal is done and we have traversal is done and we have applied the whole algorithm and the stack is empty. So if we talk about the time complexity of this algorithm, so it's order of V plus E, where V is vertex, number of vertex in the graph and E is number of edges in the graph. Now we will discuss the application part of DFS. So there are many applications of DFS. Some of them we are going to discuss. So first one is finding path between two vertices of a graph, and detecting cycles in a graph, topological ordering of a graph. So let's discuss one by one each. So first of all, we are going to find a path between two edges, or sorry, two nodes in a graph. So how we find it? So perform a DFS from the source vertex on the reaching the target vertex, output the content of the stack. So we will let's understand it by the example. So here our source node is uh, A, and target node is, or destination node is C, and we have to find the path from A to C. So we will use the same example which we have already discussed. So as we can see that there is no node visited, and the stack is empty, and there is a graph. So the same example graph which we have already discussed. So we have to go from A to C. So we will begin from A. So from A to we will go from A to C, and when there is A in the bottom and C is on the top of the stack, then the nodes which is available in the stack is the path from A to C. Okay, so let's understand why this is completely example. So uh, meanwhile the DFS, the A is in bottom and C is on top. So now we can say that this is the path from A to C in for this example. So how is it, let's understand it. A to H, H to E, E to D, and we can see D to C. So this is the path from A to C. So so as we can find the path from two vertices by this algorithm. So we can also find the cycles. Cycles can be detected in a directed or undirected graph. We can detect cycles in both type of graph. And how we do it? We use for this we use back edges. And what is it? Edges to the visited nodes from the vertex of the top of the stack. So let's again understand it by the example. And uh, as we can see that we have gone through from A to H, A to E, E to D, D to B. Now there is a and back edge B to A already. A is already visited, but there is an edge which is directed towards A. As you can see, it's directed graph. So there is an edge from B to A. So they mean there exists a back edge. So this is a complete cycle: A to H, H to E, E to D, D to B, and B to A. So thus we can find cycle in a graph. Now let's talk about the topological sorting, how we find from this algorithm. So this is uh, only in directed graph, and an ordering of the vertices in the graph, which this gives the ordering of the vertices in the graph is give us topological sorting. For every directed edges A to B, ordering has A before B. So what's the algorithm for it? So perform DFS or DFT with a little modification. So print, what is the modification? Print the vertex after running DFS on all its neighbors. So for example, so let's suppose this is an example, and there is a it is a directed graph and or a tree, and there is a directed from. So in this example, this call 100 must be done before COL 106 and COL 215, as we can see, because this is starting as we can see that there is a marker from COL 1002 to COL 215 and COL 106. So before this is two things, this must be done. So yeah, this is before this courses, this must be done, and like same as for before this COL 351 course, COL 106 and COL 110 must be done. So as when we apply the above algorithm on it, and we can see that there is a topological ordering of this graph is from COL 100 to COL 106. After that there is COL 215, and same as there is COL 315, and then COL 226, and then COL 290. After that COL 331 and COL 719. So as we can see that it is a topological ordering of the above example. So it's same as COL 100, COL 106, COL 215, COL 351, COL 226, COL 290, COL 331, and COL 719. So this was a discussion. So this was a example and some application of DFS. So thanks, and thanks for watching.